So welcome to lecture series on design and analysis of algorithm. In the previous lecture, we have discussed about what is a flow and what a flow network is and why we go for max flow problem. So today we will see how to solve this max flow problem using Fulkerson algorithm. As we have discussed earlier, this max flow problem is an optimization theory problem. So this is particularly used for finding the feasible flow from a single source to a single target network, and this flow that is found will be the maximum flow. So as I said before, this is solved using Fulkerson algorithm. So given a graph, this graph represents the flow network where every edge has a capacity. So we will mention the weight of the edge, right? So that weight represents the capacity of that particular edge. So we will have two main vertices or nodes called as source vertex as well as target vertex. So the target vertex is also called as sink node. So your problem or your task is to find the maximum possible flow from the source vertex to the target vertex. And this maximum possible flow determining process should follow the two constraints. So those two constraints are: first constraint is the flow edge cannot exceed the given capacity of the edge, which we have discussed earlier. So when we are discussing about the flow networks, we have seen that the flow of a particular edge should not exceed the capacity of the edge. So the second constraint is the inflow should be equal to the outflow for every vertex, which is not applicable for source vertex and target vertex, because for source vertex we will not have inflow, whereas for target vertex we will not have outflow. So this constraint of the inflow should be equal to outflow is not applicable for source and target vertex. So this is the algorithm. So we will start with initial flow as 0. So initially, when there is no flow, initial flow of all the edges will be 0. And next you have to find the augmenting path from the source to the sink. So this augmenting path need not be a same. So you can choose, there will be multiple augmenting paths. So you can choose any augmenting path. So when we are choosing the second path, you have to add the flow of that particular augmenting path with the previous flow. So you have to continue this until there are no augmenting paths left. So once there is no other augmenting path left, you have to return the final maximum flow, which is the summation of all the flows of all the augmenting paths. So these are the various terms that are used in Fulkerson algorithm. First one is residual graph. So this residual graph adds additional possible flow in the given graph. The original flow capacity is represented using the terminology called residual capacity. Similarly, maximum possible flows represented using minimum cut. So this is also called as min cut max flow algorithm. Fulkerson algorithm is also called as min cut max flow algorithm. So augmenting path which is being chosen should satisfy two conditions. One is non-full forward edge. The path which is being chosen should be a non-full forward edge, and second one is non-empty backward edges. So let us discuss this Fulkerson algorithm with an example. So here a graph is given. So each graph has specific weight. Here the vertex S represents the source vertex and vertex T represents the destination or the sink vertex. Initially the flow is equal to 0. Now I am choosing the augmenting path which is S, A, D and T. So in this path, if you look into this path, from S to A the capacity is 10, and from A to D the capacity is 8. And from D to T, the capacity is 10. Of these three capacities, 8 is the minimum. So this minimum capacity is chosen as the flow. As this flow should be less than or equal to capacity, I have to choose the minimum capacity as the flow for all the edges in the augmenting path. So next step is to add the minimum capacity chosen to the flow of all the paths. So from S to A, if I add 8 to the initial flow, so initial flow is 0, so adding 8 to the initial flow will be equal to 8. And from A to D, again the initial flow is 0. So 0 plus 8 is 8. And from D to T, the initial flow is 0. So 0 plus 8 is 8. So the residual capacity of this particular augmenting path will be 8. Similarly, the next augmenting path chosen is S, C, D, T. So from S to C, the capacity is 10, and from C to D, the capacity is 9. From D to T, the initial capacity was 10, but we already have a flow there which is 8. So the remaining capacity is 2. So 10, 9 and 2 of these three, the minimum capacity is 2, which has to be chosen as the flow. So I'll be adding 2 to each of the flow of the augmenting path edges. So from S2 to C, the initial flow was 0. So 0 plus 2 is equal to 2. From C to D, initial flow was 0. Again 0 plus 2 is 2. From D to T, initial flow was 8. So 8 plus current residual capacity, which is 2. So 8 plus 2 is equal to 10. So if you see this, so flow, initially the flow was 0, and when we are choosing the previous augmenting path, the flow was 8. Now the residual capacity is 2. So we have to add this flow to the initial flow. So initial flow is 8 plus 2, current flow is equal to 10. So if you see the path D to T, the flow becomes equal to capacity. So capacity also 10 and flow is also 10, which means there is no more flow allowed in this particular path from D to T. So this particular path will be terminated. Now I am choosing the augmenting path S, C, D, A, B, T. So if you see here, the minimum flow is from S to A, it is 2, and from S to C, the minimum flow is 8. From C to D, it is 8, 7, and from D to A, we have only edges from A to D, which means the forward flow is only allowed. So already the forward flow is full, which is equal to 8. So now I'm choosing the path from D to A, which is reverse flow. So I have to subtract the flow from 8. So there reverse flow is 0, and from A to B it is 4, and from B to T it is 10. So of these flows, 4 is the minimum. So I have to add 4 to all the initial flows of the edges in this augmenting path. Whereas if you consider the edge D to A, I will subtract flow from the forward flow, because this is reverse flow. So I have to subtract it from the forward flow. So upon adding this residual energy, I'll get from S to T, C the initial flow is 6, and from C to D the flow is 6, and from D to A the forward flow is 8. So I'm subtracting 4 from that, so the reverse flow is 4. From A to B, again the flow is 4. Here the flow becomes equal to capacity, so which means no more flow is permitted in this edge A to B. And from B to T, again the flow is 4. So initially the flow was 10. Now I am adding the residual capacity to the flow. Now flow becomes equal to 14. Now I'm choosing the augmented path S, A, D, B, T. So from S to A, initially the flow was 8. So the remaining capacity is 2. From A to D, we have 4. Only 4 forward flow is completed. So remaining flow is 4. Again from D to B, it is 4. And from B to T, it is again 6. So of these values, 2 is minimum, which is from S to A, we have only remaining capacity 2. So I'm adding this residual capacity to all the edges. So if I add it to all the edges in the particular edge S to A, the flow becomes equal to capacity. So no more flow is permitted in that particular edge. So initially the flow was 14, and adding 2 to it. So final maximum flow will be 16. So next I'm choosing the augmenting path S, C, D, B, T. So in these paths, so if you see the minimum capacity is 3, so which is the residual energy. So I'm adding that residual energy to all the edges in that particular augmenting path, and that 3 is also added to the previous maximum flow. So previous maximum flow is 14. So adding 3 to 14 will be equal to 17. So now finally choosing the augmenting path S, C, D, B, T. So here the residual energy is 2. So I'm adding that residual energy to all the edges, flow in the edges of the particular augmenting path, and again adding 2 to the initial maximum, previous maximum flow, which is 17. So final maximum flow is 19. So no more augmenting path is available. So the maximum flow of this particular graph is 19. So this is how Fulkerson algorithm is applied for finding the maximum flow of a given network. Remember, this algorithm is also called as min-cut max flow algorithm. So these are the various application of flow networks and computer networks. It has technology impact, and it is used in modern lifestyle for advancing civilization, and it is also used for flourishing network. So if you want to calculate the cost versus profit, or if you want to calculate the supply versus demand, and in case of network optimization problems, this four Fulkerson algorithm is applicable. So thanks for watching. We will meet in another lecture series.